Uh, okay, good afternoon, all of you. So sorry because there was a internet problem in the institute. We could not able to connect it in time. So let us start the session. Hope I'm audible. One of you unmute and then say am I audible or not. Okay, that's going on fine. Hello, am I audible? Akshata, Akshata.
Sir, audible.
Yeah, fine. So today basically we try to understand because in last 2 days we had okay, we could able to understand okay how much you have learned or what is the gap that exists between you people and us. Okay, I want to just fill that gap maybe in this session. So let us try to understand okay how do we make sure that okay all of you meet our expectations. So let us start with basically we will take an amplifier. So let us have a look at okay what is an amplifier, how it looks like, okay what are the things we are supposed to look at in an amplifier. So let me write this is an amplifier. So when you say this is an amplifier, I'm just simply talking about a black box. So there's a black box amplifier where you can see there are two terminals at the input and two terminals at the output. So be expressive yourself, and then whenever you get any doubt, please don't hesitate to stop me, so that whatever doubt you have has to be get cleared in this today's session. So this is an amplifier black box. So I want to test this amplifier. So when I say this is a black box, so as I said, so this is the input port and this is the output port. So when I say input port, here it is where you will going to apply the input voltage, and here you are going to measure the output voltage. Let us go one step deeper into it. I said okay this is an amplifier black box. So how does this black box work? So of course it is not simply input and output. We also supposed to consider this amplifier whatever we just thought of as a black box will also have a supply voltage, because without the supply voltage nothing will work. So that supply voltage will be usually a DC supply, that is a DC voltage will be applied to it. Sorry, just a minute. Sorry. Oh, sorry. Oh, yeah, okay, sorry. We were now this is an amplifier, again the same amplifier, but we are supposed to give one more extra information, or we should know one more extra information, that okay what is the supply voltage that is usually a DC voltage that is applied to this amplifier so that it works. And again you're going to have the input voltage. So this is again the input, and you're going to measure the output voltage here. So of course whenever you consider there is a DC voltage, like there is a corresponding ground also. Let us go one step deeper into it, and then if you carefully observe, this terminal will be common for both of them. So here I said okay this is input and output terminal, but if you carefully see, one of the terminal is common between both input and output. So sorry, this is my V naught where I measure. So this is my measured. So this is the applied input voltage. So this is V in, and again I'm going to have the VDD or VCC depending on what is, and this is ground. This is again the amplifier. So you can see from here we migrated to this, so more closer to an actual circuit, so where you have a DC supply applied, and of course here you are still having the DC voltage, and this is amplifier. And one more thing here interesting is that this terminal is common. Since you are applying the input voltage with respect to ground and you are measuring the output voltage with respect to ground, such type of amplifiers are called as single ended. Please note this, single ended amplifier. So whenever I ask for what is single ended amplifier, you should say input and output. Input is applied with respect to ground and output is also measured with respect to ground. That's what is called as single ended amplifier. Then you ask me, sir, what is the different type of amplifier? Other different type of amplifier is, it can be a differential amplifier, where you can see in this particular case, since these are the two input terminals and these are the two output terminals, they are not same. Matlab, they are not the same point. They are not the same point. Suppose if you, of course, if you have a separate ground and if these two are separate, then input is not applied with respect to ground. Input is applied with respect to these two terminals. So now this is the input, this is the output. In such case, I am differentially applying the input voltage, I am differentially measuring the output voltage. So that is not the point of observation now. So what I want to say here is, if you are measuring, if you are applying the input with respect to ground and if you are measuring the output with respect to ground, I'll call it as single ended input and single ended output measurement. Is that clear, Akshata? Hello.
Sir.
Okay, now we'll go to slightly deeper into the analysis. So let us try to consider an amplifier. So what are the things you are supposed to, whenever an amplifier comes into picture, so we are supposed to measure few important, very important parameters. One of the important parameters is the voltage gain of the amplifier, and one more most important is bandwidth. So these are the two important parameters we are supposed to measure uh, to characterize an op amp. Of course, we have so many other parameters like, okay, input impedance. So what is the input impedance? What is the output impedance? These are the things which cannot be measured in remote lab, but you can certainly measure this voltage gain and bandwidth of the amplifier. So when I say the voltage gain and bandwidth, so I need to apply some input voltage, I need to vary the frequency, I need to measure the output voltage, I need to find out the response of that circuit for different frequencies. These are the two important parameters I should measure. Let us go to exact circuit. So when I say an amplifier, again I'll write the black box. I'll write the black box, and then within this black box, let me fill the actual circuit. So actual circuit may be something like this. So let me consider a CE amplifier. So I will write the CE amplifier now. Of course, unfortunately, most of you could not write a proper circuit for transistors, proper symbol for the transistor also. I don't know why it has happened so. Uh, Sorry, this is not writing with great intensity. And then this is, you can see VDD or VCC line is coming out, and this is the ground line that is coming out. So which is exactly the black box, and this is my input where I'll apply the input voltage, and here I will measure V0. Of course, we call this as R1, R2, CC, this is RC, and this is RE, and this is C. So is it similar to what we expected, what we wrote here? Is it not similar to this? So we wrote this amplifier where I had two input for the two terminals for the input, two terminals for the output, and then of course one of the terminal which is there common between input and output is the ground. But of course you had a VDD. Same thing is here. Can you see here? This is fine, Akshata?
Yes, sir.
Yeah, this is fine. Let me just make sure that this everything is off. Okay. Now I need to measure, as I said, assume that you have been given the access to this particular circuit. You are asked to find out what is the voltage gain and what is the bandwidth of the amplifier. Correct? This is what you are asked to find out. Then, how do I find out the gain of the amplifier, voltage gain of the amplifier? I know that we have to apply an input voltage and we have to measure the output voltage. So when I say input voltage and output voltage, we also know that the expression for AV in terms of practical measurement is V out by V in, V out by V in. So instead of simply measuring the peak, you measure peak to peak. So measure peak to peak of input by peak to peak of output divided by peak to peak of input. So that will give you the ratio of that will give you the voltage gain. Now the point is, how much input voltage should apply? How much input voltage should apply? So when I say I should apply a signal, the second question comes: what signal? What type of signal? Whether it is a sine wave, square wave, triangular waveform, is it a DC voltage, and all those things. For any amplifiers for that matter, we will apply a sine wave. Why sine wave is, so assume that I don't know whether maybe in signals and systems and all those things, how do you represent a sine wave in frequency domain? Will you not represent it by a delta function at that particular frequency? Anybody there? Hello? 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 Akshata, are you there?
Yes, sir.
No, I think okay. You can represent any signal in frequency domain and time domain. Am I correct? Is it being told?
Yes, sir. Yes, sir.
Okay. Now you can see there is a sine wave with a frequency equal to f. So will you represent it by a delta function on the positive side at f, and there is one more delta function at minus f? Correct. This is only for sine wave. Assume that you have a square wave of same frequency f having a time period t, then this will going to have n number of frequency components. It will not have only one frequency f, it will have so many harmonics. So since I want to analyze this circuit for only one frequency of a signal, so I will choose the type of the signal is a sine wave. It should be a sine wave. The DC signal is not accepted because it will going to block the DC. Correct? So DC signal I won't apply. I will apply only the sine wave. So once it sine wave as your signal, then comes what is the amplitude. What is the amplitude of the signal, and what is the frequency of the signal, and what is the offset of the signal, and what is the symmetry of the signal. So why I'm saying all this is because if you go to this one here, can you see here in this wave gen you have these many things? Hello?
It's not visible, sir.
Oh, wait. How about now? I think it's visible.
Well,
Hello?
sir.
Is it? Hello?
Yes, sir.
Yeah, these are the parameters I should
Yes.
fix. You can see this is the sine wave, frequency, amplitude, offset, symmetry, and phase. These parameters have to be set. So now it comes to what is the amplitude of the signal. So we know that. Do we know this? What gain of the amplifier? So is AV is equal to V out by V in? Is it known to all of you? Hello.
Yes, sir.
Now, this is the expression for the output voltage in terms of measurements. So, in terms of actual circuit, what is AV is equal to for this particular expression? For this particular circuit, it is minus GM into RC by 1 plus GM into RE dash. This is the design wise. This is the design wise. This is what? The measurement wise. How do you measure? How do you get it? How do you get it? Correct? Now, somebody should
Sir.
respond.
Yes, sir.
Okay, now
Yes, sir.
fine. Now the question is, what should be my amplitude? So what should be my amplitude? So assume that this amplifier has got a supply voltage of 5 volt. Of course, we know that in our remote lab the VCC is 5 volts. Correct? VCC is 5 volts, and of course you know that the output will always swing from 0 to VCC. Correct? That is 0 to 5 volt.
Yes, sir.
So 0 to 5 volt is the swing available. Ideally, we fix the center point of the swing at 2.5. Ideally. Correct? Hello.
Yes, sir.
So
Yes, sir.
this is the available swing. So it can swing from here to here. Am I correct?
Yes, sir. Correct, sir.
So assume that you don't have this much overall swing. Just take 90% of the swing. 90% of the available swing, because you are supposed to keep this in active region and all those things. What is 90% of 5? Is it not 4.5 volts?
4.5.
4.5 volts is 90% of the available swing, out of which you take half of it, because this is now peak to peak. Am I correct? Shall I say this
Yes,
is
sir.
V naught max peak to peak? Hello?
Sir. Yes, sir.
This is V naught max peak to peak. So what I'll do, I will write AV is equal to V naught max peak to peak by V in max peak to peak. Correct? Assume that AV of an amplifier is something like 50. Assume that if the gain of the amplifier is 50, if this is 4.5, shall I write it as 50 is equal to 4.5 peak to peak by V in max? How much is that V in max then?
Yes, sir.
How much is V in max? Because yesterday most of you are struggling, so to tell the what should be the input amplitude, this is one such possibility. If the gain of the amplifier is 50, so is it not 4.5 divided by 50? Is it not 0.09
0.09.
volt, which is nothing but 90 millivolt? What is this 90
Sir.
millivolt? This is peak to peak voltage. Correct?
Yes, sir. Peak to peak
So what should
voltage.
be V
Peak.
in amplitude? So it should be 45 millivolts should be the amplitude. This is the maximum amplitude you can keep, provided gain is 50 and the available swing is 4.5 peak to peak. Correct?
Yes, sir.
Is
Yes,
there
sir.
any issue here to anybody? Because I have to set the amplitude. Assuming this gain to be 50, we are trying to find out what is the maximum possible input voltage you can keep, because I have to keep this input amplitude, no? I have to keep this input amplitude. So 45 millivolt is the possible voltage, provided your assumptions are true. Correct? Hello.
Yes, sir.
So
Yes,
I
sir.
have to keep my input voltage less than 45 millivolt peak, even if it is 20 millivolt, it is fine, so and so. Correct?
Yes, sir.
Can
Yes, sir.
somebody tell me, if AV is equal to 20 volt per volt and V naught max available is, of course, this I'm talking about the swing. If it is equal to 3 volt, this is now peak to peak. Can you tell me what is V in max I can have? V in max peak voltage. This is peak to peak. This is I want peak voltage. Is it not uh, 3
0.15.
by 20? How much is that?
0.15, sir.
Is it how much is this? 3 divided by
1250.
20. It is 0.15.
0.15, sir.
0.15 volt, which is nothing but 150 millivolt. It is what? Peak to peak. Correct? This is
Yes,
peak
sir.
to peak. No,
Yes, sir.
this was peak to peak. So this is peak to peak. So what should be V in max in terms of peak voltage? Should be 75 millivolt.
Volts.
Correct?
Yes, sir.
Fine.
Yes, sir.
Of course, this is not, you are simply dividing the what V naught max by AV, and then you are trying to fix what is the input amplitude. Then comes, okay, we are through with this amplitude. Then comes what is the frequency. We know that this is a C amplifier. Of course, whenever you are doing the experiment, you have already learned the frequency response of this amplifier. Is it correct? Since the frequency
Yes, sir.
response of the amplifier is known to student before the conduction, we know that the frequency response of an amplifier looks like this. It is increasing as the frequency increases, becomes constant. This is frequency, this is AV gain. Can you see it is increasing, becoming constant, again comes down? There is a range of frequency where I can
Yes, sir.
keep it. And using the equations, using the design problems, we know that this is in terms of maybe 3 kilohertz or okay, 300 hertz or so on so, and this was in terms of maybe few hundreds of kilohertz. Correct? This can be 500 kilohertz or 600 kilohertz. Can you see now, the range of frequency is in from tens of kilohertz to hundreds of kilohertz. Shall I
Yes,
keep
sir.
the frequency as 20k, 100k, 50k? Is any frequency fine? Because you can see over that range of frequency, it's almost constant. It's not necessary that it should be always at 20k. It's not necessary that it should be always at 50k. It can go up to 100k also as long as it is constant. Correct? How do we get to
Sir.
know is you can do a simply do a what is that network, and then you'll get the information. So we have some range of frequency, and you can see the frequency cannot be in terms of hertz. Why it cannot be in terms of hertz? It cannot be in terms of hertz because in hertz the gain is okay. One more thing, the gain what we are trying to measure is the gain in mid band. So let me not simply say the voltage gain. I want to know what is mid band gain. Is this visible? Mid band
Yes, sir. Yes.
voltage gain. Mid band matlab this is lowest band, that is the highest band. In the middle of the frequency, how it looks, that's what I'm interested. So since it is sorry mid band, I have to keep the frequency where the gain is almost constant, which ranges from tens of kilohertz to hundreds of kilohertz. Is that point clear?
Sir.
So amplitude you should decide depending on what is the possible gain. Frequency you should decide depending on what is the range of maximum gain. So this will be usually from tens of k to hundreds of k. So it can be from 10k to 500k, 600k, 800k, something like that. Correct? And the offset should be 0 volt. I should not apply an offset voltage having an input amplitude with some DC offset. And symmetry, let it be 50%. 50% means it should be a pure sine wave. And then you have one more thing that is called as phase. Let it be 0 degree. So let us not have any phase shift at the input itself. Correct? Okay,
Yes,
what
sir.
we'll do, we'll just go to this one. I don't know whether you people have noticed it or not. Okay, we are trying to conduct an experiment of C amplifier. You can see this is my C amplifier. Uh, we have got, of course, as we already discussed, we can vary the value of R2, RC, RE dash, and CC values. We'll just come to that later. Now, in this is one possibility. So this is a simple wave generator which will generate a given shape at a particular frequency with some amplitude. This amplitude is peak amplitude. So if it is 0.2 volt, the peak to peak is 0.4 volt. Is that perfect? Hello?
Sir. Yes,
The
sir.
amplitude is always peak amplitude. If you want to apply 5 volt peak to peak, sorry, 0.5 volt peak to peak, then it should be 0.25. Correct?
Sir.
Okay, let me just assume that, okay, if this is so and so, I will go back to, okay, I'll take out the scope out and then I will run it here simultaneously. Okay, I will just put it here. Are you getting the waveform properly now? Because we have applied 0.2, it is fine. Correct? Uh,
Sir.
what we can do is there is one more possible option here. Let us try to explore what are the options in your wavegen. Can you see there is one thing called as basic? In this
Sir.
basic, you can able to change the frequency. You can just sweep here. Can you see here? Can you see the same thing is changing here? Hello?
Sir. Yes,
Can you
sir.
see change the you can change the amplitude also here? Can you see here?
Sir.
Can you see it is becoming clipped off after some time? Can you see here?
Yes,
This
sir.
is clipping.
Yes, sir.
So what does this mean is you cannot put an amplitude something in this range so that it is clipped off. So I need to keep it down. I need to keep it down here. Can you see here? If I'm reducing, is it now coming fine? Is
Sir.
this okay now? Can you see, is it fine now? Again, the offset should be 0. Of course, what does symmetry mean is, suppose we just make something like this symmetry. Can you see the shape of the waveform? This is not pure sine.
Yes, sir.
Make sure that this is 50%, sorry, 0. sorry, 50%. That is pure sine wave. This is one possibility where you can manually change, and there is one more possibility here. Can you see there is a sweep? You can select sweep option. See here. Can you see here? I can sweep two parameters. I can sweep the frequency. I can sweep the amplitude. Akshat, are you there?
Yes, sir.
What I'll do is I'll keep the frequency at 20 kilohertz. I'll keep the frequency at 20 kilohertz, a constant frequency, and I will change the amplitude from 0.1 to 5 volt in 1 minute. This is possible. Can you see here on the left hand side? Can you see this is keep on changing here?
Sir.
What
Yes,
does
sir.
it mean is I will start from 0.1 volt and I'll be keep on increasing it to 5 volt. I want to see how does my circuit behaves. Correct?
Yes, yes, sir.
I will go back to my oscilloscope. I'll go back to my oscilloscope. Can you see now? Just this is giving the variation for 0.1. Of course, you can clearly observe the input is keep on increasing. Can you see that?
Yes, sir. It is increasing, sir.
Just see, it will actually start from 0.1. Of course, you are there in the midway now. So you can see it will come down to 0.1. Can you see it's keep on increasing? Once it goes to 5, it will again, that cycle repeats. Can you see now? Hello?
Yes, sir. Yes, sir.
So
Yes, sir.
it has already become clipped off. Hello?
Sir, it is clipped off, sir. Yes,
Clipped
sir.
off because your input is more. So
Sir.
what I'll do,
Yes, sir.
I'll not make it up to 5 volt, I'll make it up to 0.5 and then I will rerun it. Correct? I will stop it and
Sir.
then run again. Can you see now this is keep increasing? Can you see here?
Yes, sir. Yes, sir.
Maybe let me just make this also different range so that you can make out. Can you see it is keep increasing? Because in 1 minute it will increase from 0.1 to 1 volt. That's what is the range I have set. Can you see it is becoming clipped off here? It's clipping off.
Sir. Yes, sir.
I
Yes,
think
sir.
some of you have a what doubt. So this is showing 500 millivolt. How it can clip off? Anybody has any such doubt? Hello. Can somebody tell me what is the voltage of this blue line at this point? Hello.
Yes, sir.
How much the voltage of this blue line at the top? Looking at this, someone tell me something. Some number you pick it. Is it 500 millivolt there?
Yes, sir.
It is not 500 millivolt because can you see there is a C1 C2?
Sir.
This C1 corresponds to channel 1 because can you see in this channel 1 there is a range of 0.1 volt per division. Respond, I say. Hello. Who has got the better network? At least somebody should respond to me. Hello.
Yes, sir.
See here, this 500 millivolt corresponds to this 0.1 volt per division. Can you see this is 100, 200, 300, 400, 500. Do you have 5 divisions here?
Yes, sir.
That 5 division corresponds to channel 1. But I am
Yes, sir.
interested in knowing what is the voltage of this blue one which corresponds to channel 2. Correct?
Yes, sir. Yes, sir.
Channel 2 has got a range of 1 volt per division, but it is not shown here because you
Yes,
are
sir.
not selected that. Now I will select. Can you see now it has changed?
Yes, sir.
This is one key thing. If you want to measure from here, if you want to know what is the voltage, this corresponds because you are interested in the output now.
Yes, sir.
Can you tell me what is the peak voltage here now? It is
So it's
5.
500.
It is 5.
Yes,
Of
sir.
course, it is 5 because you are looking for channel 2 and you have selected channel 2. Suppose if it was like this, can you say channel 2 voltage is 500 millivolt?
No, yes, sir.
Hey, how come, man? This is corresponding to channel 1, no? LO1.
Yes, sir.
I am
With
asking
respect
you
to
what is the voltage of this channel 2.
no, sir, we cannot determine.
So, if you are measuring channel 2, you need to highlight that C2. you
Yes,
should
sir.
have the volt per division corresponding to C2 there.
Yes, sir.
So I will again redo it. Can you see now it is keep increasing?
Yes, sir. It's keep on increasing.
So now can you see what is the possible input voltage where you can get it a clear waveform? Can you see are you still getting it?
Yes, sir. And now
Can
it's
I say what is the amplitude of my channel 1? Is it around 300 millivolt?
yes,
Around
sir.
300 is already clipping.
Yes, sir.
Is it somewhere 200 better?
Yes, sir. Don't no. It's clear there.
So now what I'll do, I'll go back to, I'll take out the sweep, go to simple, I'll make it 200 or maybe somewhere around 100 millivolt, and I know that frequency should be in the mid range.
Yes, sir.
So
Some
it can't be
kilohertz.
100 hertz. So it should be
In terms of kilohertz.
20 kilohertz. Can you see now? Are you now getting it?
Yes, sir.
Now this sweep will give you an idea what should be the amplitude.
Okay, yes, sir.
Are you all getting? Now this
Yes,
sweep
sir.
has actually ensured you. Can I vary? Can I keep 1 volt? If I keep 1 volt, will it work?
No, sir.
Because for point 3 itself, can you see here? Now it is
Just
around
clipping
class
off.
point 3. It is already started clipping.
Yes, sir.
So this will give you some information, and it is not same for all selections, because this is for
Yes.
which one? This is for
C1.
maybe C1.
C1.
For C2 or C3 it may be different. See here now,
Yes,
this
sir.
is for C16. I will stay at conduct. What I'll do, I'll just go back to this here and I'll again restart. Okay, let it go up to 5 volt, because now it is you're given 1 minute time to go from 0.1 to 0.5. Okay, let it start from 0. So let it start from 0.1. Can you see now?
Yes, sir.
Is it perfect? So
Oh,
now
no.
it has crossed even. Now it will be crossing 200.
Yes, sir.
Now it will cross 200. It is fine because it is still within that
The
range of
limits.
5. Can you see it has crossed almost 220, 230?
Yes, sir.
Can you see here it is clipped off? This is
Yes, sir.
interesting.
Started.
Here it is started clipping off than the top.
Yes, sir.
So what is the amplitude? Somewhere around 250 is
Two,
a better amplitude.
yes, sir. 220 to that.
Correct? So
Yes,
that's
sir.
what. You can keep it, if you're keeping it at around 100 millivolt, it is safe.
Sir, why
And
it's even in bottom it is clipping off?
because what I'll do, okay, let me just show you that. Suppose if I switch off this, what will happen? If I take out, what will happen? Okay, for this
It will
circuit,
stop, sir.
if I switch off this input voltage, what is my output?
Zero, I don't.
It is DC voltage. Because as I said here, this is when you apply the signal, it will come. If you don't apply the
Yes,
signal,
sir.
is it not the DC voltage?
Only, sir. 2.5.
No, it will be ideal 2.5. You can see what is that DC voltage if I don't apply anything. Can you see now? I will not apply. Can you see this is DC voltage? What is DC voltage? This is around
Around
2.8.
2.6. Yes, sir.
2.8 for what? C16.
Yes, sir.
Shall I just go to C1 and then try to find out? You can see now it is more closer to here. I'll make it to C1 and then run. Can you see as it shifted?
Yes, sir. It has
Since it is
increased.
closer to VCC, that was clipping faster.
Yes, sir.
That was clipping earlier. Because
Yes, sir.
this is closer now. How much is the swing available? Swing available is less, and here it is more. But for C16 it is not so. It's almost at the middle. Can you see here?
Yes, sir.
What
Hence,
is this
in
actually?
downwards only it will start.
What is this voltage?
Mid band to
No. What is this voltage? This
DC
is
voltage, sir.
the collector voltage of your amplifier.
Yes,
Am I
sir.
correct? So what is that voltage? That is 2.8.
Yes, sir.
So around 2.8 it will swing. So you have almost closer swing. Of course, it is reaching bit closer here than at the top. Now what I'll do, I will go back to my wavegen. Now what does this actually give you is, so it will give you an idea. Of course, you have to be careful. Okay, from where to where I should swing. So you cannot swing from 1 volt itself. Can you swing from 1 volt?
No, sir.
Of course, you
It's
can
not in range,
certainly
sir.
swing from 1 to 0.5. You can't. There is no point in sweeping from 1 to 2. Will it happen? Suppose if you
No,
start
sir.
doing it from the initial voltage itself, it is clipped off
Yes, sir.
because you are already crossed that point. So that's why you always start from a lower voltage, zero point 0.1 to maybe around 1 volt. Can you see now it is keep increasing?
Yes, sir. It started clipping off.
Of course, you can just make 1 or 2 iterations. Just try to find out at what input amplitude it clips off. So how do you make out the input amplitude? That's over here.
By checking.
So you have to click on this C1 so that will give you 100, 200, 300. Let it be in hundreds of millivolts. So don't keep this in 1 volt per division. If you keep it in 1 volt per division, it's very hard to make out.
Yes, sir.
So of course, correspondingly, of course, by practice you can able to choose proper amplitudes. One second. Okay, this is about the what is that? Amplitude.
Okay, sir.
So
Right.
this will give you an information about what should be the amplitude. Correct?
Yes, sir.
So what I'll do, let me keep the amplitude at, let me not sweep it, let me keep it at 0.1, let me sweep the frequency. Let me sweep the frequency from maybe 100 hertz to maybe
Sorry,
around
kilohertz.
500 kilohertz in 1 minute. Okay, let me just make it at 1 minute. Carefully observe this, how it happens.
Yes, sir.
Can you see here? Okay, you can carefully observe this peak to peak amplitude. I will again redo it. I just made it. Oh, sorry, this is fine. Maybe let me further reduce it to maybe 10 hertz. Can you see here the amplitude is keep increasing?
Yes, sir.
So once it reaches, you can see it's almost 2 volt now. When it actually
Yes.
started, suppose assume that okay, I'll just not make it so and so. Let me make it somewhere at 2 kilohertz.
Yes, sir.
Just have a look at your peak to peak amplitude of the output voltage. I just intentionally made it from 110 hertz to 2 kilohertz.
Yes, sir. It's keep from 0.09 it started.
Can you see it is still in the increasing portion of your graph? Let me just show you
Yes,
this.
sir.
Is it now in this portion? Is it now in this portion of increasing?
Yes, sir.
You'll be still there. You're not at all reached the peak of it. So let me just show you that again. Can you see it is still there? Because you are still at 2 kilohertz. Can you see it is keep on increasing? Just have a look at
Yes,
this.
sir.
Does it keep on increasing?
Increasing, sir. Yes, sir.
0.62. It has not yet still become constant. Can you see
Yes,
the
sir.
what is that? Waveforms are coming closer
Yes,
because you
sir.
are increasing the frequency. It is still in the increasing mode.
Yes, sir.
You can say because you are there in that positive slope of your frequency response. Now you can see it again started from 10 hertz.
Yes, sir.
Now this is
Right.
not a good sweep. Let me just do it up to maybe 10
20.
kilohertz.
Yes, sir.
Can you see now it is keep increasing, keep increasing?
Yes, sir.
Can you see now it is keep on increasing at some point it will become maybe almost 2 volts
Yes, sir. Yeah, it's increasing, sir.
because you are almost there increasing. Can you see it has become 1.2, 1.6, it is 1.3, 1.6, 1 point, okay. You're still in the increasing mode.
Yes, sir.
Now this is like okay sweeping the frequency, increase the frequency. It went up to 1.67. So once it reaches 10 kilohertz, it will again start from 10 hertz or whatever the initial frequency. Now,
Yes,
why
sir.
I'm showing this is, so this will give you some information about what should be my frequency, because I need to keep the frequency, no?
Yes, sir.
Can you see it has almost become 1.8? Almost constant,
Yes,
you can
sir.
say 1.8. Now it has started. So you can keep it anything frequency after 20 kilohertz when you go to a simple range. So that's why we keep it 20 kilohertz and 0.1, because 20 kilohertz to suppose if it is 20 kilohertz, how much is peak to peak here? Is it not 1.98?
Yes, sir.
Let me just make it 100 kilohertz. Is it still the same?
Yes, sir. 1.9.
If I make it 200 kilohertz, is it still the same?
Yes,
Almost.
sir.
Meaning this is in the band, in that mid band.
Yes, sir.
See here, this is starting from 10 kilohertz, 20 kilohertz, 50 kilohertz, 100, 200. You are there in this entire frequency range. When I ask you people what should be the frequency of the input signal for C amplifier, don't stick on to 20 kilohertz. It can be any frequency in the mid band range. It can range from 20 kilohertz to 200 or 300 kilohertz.
100 kilohertz.
Is that clear?
Got it, sir. Yes, sir.
This information you'll get it in a single shot in your frequency response. That's why we do frequency response. See here, I will run it again. Whatever amplitude you kept in the time response, the same thing should be kept in your amplitude here. Can you see here? This should be, maybe of course 0.2 is fine. You start from a low frequency. Why I should start from a low frequency? Because I have to get the response from lowest frequency, keep it from 50 hertz, go up to 10 megahertz, you sweep. Shall I do it?
Yes, sir.
Now this is nothing, but you have to understand exactly what we are trying to do. I think we are in C16. I don't know where we are.
Yes, sir.
Now I can
C1, sir.
stop. Okay, C1. Can you see now? This is my frequency response. So we were actually struggling to get. Only thing here is that you can sweep the frequency. You cannot sweep the amplitude here. Amplitude should be constant. The frequency should be swept from low frequency to higher frequency. Can you see here? We were actually in your, what is that, wave gen. Are we actually looking at, okay, what should be this frequency? What is that here? Are we
Yes,
just
sir.
struggling to get from 10 kilohertz to 20 kilohertz, all those things? So that information you'll get it in a single shot. So can I keep my mid band from here to here?
Yes, sir. A constant voltage.
Is it somewhere here? Is it from maybe 7 kilohertz to almost 560 kilohertz? Or
Yes,
maybe
sir.
let me just slightly bring it back here. This is ideal flatness.
Yes, sir.
Range is 10 kilohertz to almost 300 kilohertz.
Yes, sir.
Fine. And the corresponding phase, you can see, of course, phase is not exactly minus 180. Minus 180 is somewhere here. So can you see here? This is almost minus 180.
Yes, sir.
If you are looking at exactly minus 180, the range of frequency is from 26 to 100. Correct? Can you see it's
Sir,
almost
why?
plus 180, minus 180?
Yes, sir.
Almost there. Of course, minus 179 or minus 172 is fine, very close. You will not get exactly 180.
Yes, sir. Sir, why the phase should be exactly or
Because
approximately
it is out,
180 degrees?
because the phase will not be 180-degree for all the frequencies.
Yes, sir.
Because as the frequency changes, the phase will also change. So we are looking at phase will be exactly out of phase whenever you are there in the mid band. You can see this phase of 180 degree and 172 is not too far away. Even 159 is not too far away from 180 degree. So you can still consider. You can still what I'm asking you is, if you are looking at exactly 180 degree out of phase, so this would be an ideal frequency. Otherwise, if you are looking at simply a maximum gain, so this is the entire range of frequency.
Yes,
Correct?
sir.
Any questions here? Now, basically what we are trying to introduce you here is that, because most of you are struggling to tell me what is the frequency and amplitude and this thing. So I think this will going to give you some information. This is in case of C amplifier. You go to the operational amplifier, you can just take an inverting amplifier and then select inverter 1. So now,
It changes this.
okay, I'll just go to network. Where is my network? Sorry. on the network. Oscilloscope. Let me run this. Let me conduct. I don't know where is my wavegen. Let me just take this inside. My wavegen is off. Let me just turn on the wavegen. Can you see now it's coming? So wavegen.
Yes, sir.
Let me just. Of course, I'm sweeping now. I'm sweeping the frequency from 10 hertz to. Okay, let me not sweep the frequency. Let me sweep the amplitude. We are starting with 0.12. Let me just make it 2 volt in 1 minute. You need to click this in 1 minute. I'll do it, and then you can see the scope.
Yes,
I
sir.
will just a minute. Just have a look at the output amplitude also. You can see since I made it from, I have to change the scale of this one. Let me change this. Okay, both of them are 1 volt. Okay, let me make this also 1 volt. Can you see it's already clipped off?
Yes, sir.
So you should know the output should not be clipped off one. So what do I mean by clipped off? It should not be a distorted.
Distorted.
Distorted. That's what is distortion means. Now, okay, let it start again. So I will ask someone of you, and then some of you just try to tell me what is the range. So let me make it 0.2 here. Oh, 0.2 is too much. What is the range I'm sweeping? Range I'm sweeping is okay. Let me make it only 2 volt. That's fine. Okay, let me go back to scope. Tell me quickly what is. Just keep on observing your input range. At what input voltage it clips off? This is your channel 1. LO is channel 1. Can you see now it has 0.4?
Yes,
It's
sir.
crossing 0.4.
Yes, sir.
Just have a look at this peak also, or this peak also. Wherever it becomes clipped off, you have to tell me.
Yes, sir.
Now it is crossing 600.
Yes, sir.
650 close to.
Clipped off, sir.
There. Can you see by around 700 it has clipped off?
Yes, sir.
What is the corresponding amplitude? You can just come down to here. Can you see it is, this is 4, this is around 3.5. Of course, I can take my cursor and then place it here. Is it, okay, I can just measure that. Can I know what is the amplitude of this one? What I'll do, I'll take a cursor and then place it here. What is the amplitude? Is it not 3.6?
Yes, sir.
What is the minimum? Minimum is minus 4.3.
Yes,
Can you see its bottom is less clipped and at the top it is more clipped because
Yes,
it
sir.
is saturating bit more, and this is not. It is saturating at a later voltage.
Yes, sir.
See now, for this particular amplifier with inverter 1 as the option, it can go up to 0.6 volts. Now what I can do, I can go back to wavegen. I can keep it. Where is that? I
Up to
can keep
0.5.
it simple. I can keep it 0.6. Frequency can be 200 hertz. Now we'll just come to this frequency later. Maybe now I'll keep it at 200 hertz and then we'll again run it. Where is that? I'll go here and then run. Can you see now? Are you getting it properly?
Yes, sir.
It's not clipped off because you saw it in the sweep. It was clipping beyond 650. You kept it 600. So that's why you're safe. So what I'll do, I will select amplifier 2. Can you see in amplifier 2 it is 10k 10k gain is 1.
Yes, sir.
Now you can just again go back to this wavegen. You can sweep it from 1 volt to 5 volt. You can go up to 5 volt.
Yes, sir.
Because gain is 1 in 1 minute. Let me just go here. Can you see it is keep increasing?
Yes, sir.
1 second.
Will it
Okay.
clip further?
Let me just show you that. 1 second. I have not selected this. I have not conducted this. Okay, now 1 second. Give me 1 second. Let me change this scale also. Oh, sorry. Can you see now? Both are increasing. Gain is 1.
Sir. Yes, sir.
Input has gone beyond 3.
Yes, sir. Let's keep on increasing.
Now it will clip. Can you see at the top it is clipping, started clipping.
Yes, sir. Sharp.
So now input for
Up to
this
4.
amplifier can be up to 3.4 volts or 3.5 volts. Why input can be so large? Because your gain is less.
Yes, sir.
As we saw in this expression, what is V in max here? V in max is nothing but available swing divided by the gain. Correct? If the gain happens to be 20, you had a 75 millivolt. If the gain is 1, you can go close to the peak to peak available in your output swing. Correct? How much the swing available here from 0 to this peak? Is it not 3.5 volts?
Yes, sir.
So you can go up to that. So your input can be up to how much? 3 volt. So what you can do,
Yes, sir.
of course you can have a look at that. Can you see there? C1 is almost 3.6. At
Yes, sir.
3.6 it is clipping. So what I'll do, I'll stop this sweep. I'll go to simple. I'll keep this at 3.2
Yeah.
volt. Just see whether it is clipping or not. Is it clipping? No,
No, sir.
it is not clipping. It is fine. Whereas the same voltage, can you give it to inverter 1?
No, sir. Gain
It
is
will
less.
clip off. It will clip off. Why the
Gain is
amplitude
more,
is
sir.
not constant? Because that purely depends on the gain.
Yes, sir.
So I want all of you to just make these clarifications. Don't say that for operational amplifier it is gain is 1, for that it is 0.2, 0.3. It purely varies from amplifier to amplifier, that too depending on what is the gain of the amplifier. And let
Yes,
us
sir.
have a look at, we always say for operational amplifier you keep the frequency low. Let us have a look at that in your network. Now you can see, let it be, since I have selected, okay, let me select inverter 1, and then run it. Then let me run this also. Just have a look at this. Can you see it is now flat here,
Yes, sir.
and then started coming down.
Yes, sir.
Now you can stop. We are now looking at what is the DC gain.
Yes, sir. It should be constant.
Can you see now the frequency can go up to only this flat? Can you see it is
Yes, sir.
around 27 kilohertz? I can't go
Yes, sir.
to frequencies like, okay, 100, 200 kilohertz, because at 100, 200 kilohertz gain is reduced.
Yes, sir.
So I have to keep any frequency below this 27 kilohertz, then only I'll get a DC gain which is almost flat. This
Yes, sir.
information I will get it in what?
The border plot.
Bode plot. See now, for the same point I'm getting it properly. How much is the gain here? Can you see it is 14.7 dB? How much is
Yes, sir.
14.7 dB corresponds to?
10 power 14.7 divided by 20.
Okay.
So 5.43.
It is
You
that
can
much
change
is the
it.
gain now. 1 second. Okay. This is because I've kept it. Okay, this is the expected gain. You can see what happens. Suppose if I unnecessarily increase the amplitude and run it. How much was this? It was 14 point something, no?
14.7. Yes, sir.
Now you see
14.7.
what's the gain. Gain is 7.8. I didn't choose a different
Okay.
amplifier. For the same amplifier, it is giving different gains. Why?
Yes, sir. Since it's distorted. Or
Output is distorted. Suppose if you go back to this scope and then
run
apply
it
2
again.
volt, what I'll do, I'll apply 2 volt. Okay, maybe 2 volt here, and I will run it. Can you see it is clipped off?
Yes, sir.
If you find the gain, it is exactly that whatever gain you're getting, but this is not an actual gain because it is clipped off.
Yes, sir.
At the point of measurement, at the time of measurement of gain, the both input and output should be sinusoidal. Then only you're going to find out the gain. So since it is not sinusoidal, you're not properly getting the gain. So what should be the shape of the output waveform? Should be a sinusoidal.
Sinusoidal.
That you will get it with reduced amplitude. I'll make it around 0.1. You're there. Now you can find the gain. Same
Yes,
thing is
sir.
valid here. Even in case of network, you have to apply suitable amplitude so that it is an undistorted waveform. You cannot make out the distortion here. But if the gain is not coming to the expected, means you have to think that okay, you might have applied larger amplitude.
Yes, sir.
And there
That
is
is
no
really clear.
point in going up to 9.5 megahertz because you are seeing so many unnecessary things. So you can truncate
Yes,
some
sir.
area. Can I just sweep it up to only 100 kilohertz?
Yes, sir. It's
That
far
is
more
fine
better.
here. I can stop it at 100 kilohertz. That's what is more than enough. You can see this is what you expected. You are getting it. You are getting it. Suppose now we
Yes,
can see
sir.
this much space is wasted. This much space is wasted. In such case, you can stop it. Since the top is hardly 20, you can make the top as around 30 dB and
Yes,
range
sir.
you make it around 40 or 50 so that you can able to see a proper waveform. Can you see it is better now? Far better, or you
Yes,
can
sir.
further reduce it so that you can able to get a good response. So you can further make this 25 dB. Can you see now it is a better in terms of frequency response? You can see the phase is almost 180 degree.
Yes, sir.
It's almost 180 degree. Of course, you will going to put
Oh,
two cursors, one
constant.
in the DC gain and one more, so that the delta delta y is 3 dB. Correct?
Yes, sir.
Any questions here? Now, basically, what I want to make things clear is that never ever fix the amplitude and frequencies. So when we ask you what is the range, you should be in a position to find out what is the input amplitude that you can apply. Maybe for inverter 4 or 5, if I ask you to find out what is the input amplitude, because for inverter 5, what is the gain here? So gain is more than 10. More than
Yes,
10.
sir.
In such case, I cannot apply larger amplitude because you know what is RF and R1. So I'll go back to this. I'll just see this also. Suppose if I apply larger amplitude, something like 1 volt, I'm in trouble. If I apply
Yes,
1
sir.
volt and then run, if I, okay, I'll just run this and I will run this also. Can you see is it clipped off?
Yes, sir.
Because it is inverter 1, it is, sorry, inverter 5 gain is more than 10 and it is 1 into 10, you're not getting 10 volt because you cannot get maximum 10 volt here. Maximum you can get is 3.5. So what I'll
Yes,
do,
sir.
I will reduce the input amplitude to a lesser
0.2.
amplitude, maybe 0.1, 0.2, that is fine. Now you're getting it.
Yes, sir.
And what should be the frequency? One of you can just find out what is the gain here. Can you see the gain is how much? This is 2.42 divided by 2.42 volt divided by what is the input? Input is 0.4. 0.4 peak to peak. How much is 2.4 divided by 0.4?
6.05, sir.
How much?
6.05.
6.05 is the gain of the amplifier when the frequency is 200 hertz.
Yes, sir.
Assume that by mistake I went to something like 100 kilohertz. Can you see what is the gain? It's so much distorted because 100
Yes, sir.
kilohertz you are there somewhere here, so
It's
you're in trouble.
completely out of it.
So you may not get it. So what do? Make it around. So that's why we
75.
ask you to make it. If you even if you make it 50 kilohertz, I think you'll be in trouble. Let me see here. Let me go to scope. Can you see you are still not getting a proper waveform because the op amp is ordinary op amp which cannot able to cope up with such a high frequency. So you still
Yes,
reduce
sir.
the frequency. You can make it around 5 kilohertz. 5 kilohertz is fine. Can you see at 5 kilohertz you're getting it as expected?
Yes, sir.
2.4 was there, now it is also 2.4. But you can see some distortion there here.
Yes, sir. At the bottom.
So make sure that you are operating at a low frequency. So that's why at low frequency it is better. Can you see it sets a low frequency? If it is 5 and 6,
Yes,
can
sir.
you see these type of small distortions available? Make
Yes,
sure
sir.
that you are there from 100 to 1 kilohertz or in that range.
So then this op amp works only for low frequency.
This
Possibly
is
works for low
the op
frequency.
amp. Okay, now we can see this depends on what is the gain. Suppose if you reduce the gain, you can go up to larger frequency. So what I'll do, I will select inverter 1, inverter 2 option. inverter 2 option. Let me just go back to this wave gen. Let me make it 1 volt. For 1 volt it was clipping, no?
Yes,
For
sir.
1 volt it was clipping. Okay, and
So
then if I
0.6.
select what is that, inverter 2, this is fine. Even if the frequency is more, it is fine. You can see now you are getting a gain of almost 1. Even if I increase the frequency beyond 10 kilohertz, it is fine. Can you see here?
Yes, sir.
This is fine, because if you reduce the gain, bandwidth increases.
Yeah.
Are you not
Yes, sir.
reducing the gain here? Here gain is
Sir,
1.
yeah.
Their gain was more, 6 point something. When the gain is more, the available frequency for amplifying that signal is less.
Yes, sir.
So the same signal I cannot get it at a larger frequency. See here now, at a larger frequency, can you see this distortion?
Yes, sir.
Because it cannot cope up. The op amp cannot respond so fast because its bandwidth is limited.
Yes, sir.
That's why maybe in your labs land we have used 2 op amps where the second op amp OP37 can still handle for larger frequencies because it has got a better
Open gain.
open loop gain. I don't know. Okay, what else to say now here? Okay, what I'll do is let me reduce the frequency to a lower frequency. So that's why it's not always 100. Even if you keep it 1 kilohertz, no issue. As long as you are there in the range of midband. Now you can see it is still clipped off. If it is clipped off means I have to go back to my amplitude and then reduce it. That again depends on what is your gain you're expecting or gain that you're looking at.
Yes, sir.
Now here, in case of op amps, even I can apply a DC signal. I can apply a DC signal of offset of maybe even 0.5 volt, maybe may not be 0.5, maybe 0.2. Can you see? Are you getting now? I
Yes,
can
sir.
able to get a negative voltage because there is an
Yes,
offset
sir.
here. Let me make that offset 0. Can you see now? It is input is okay. I should not measure. Can you see almost minus 0.1 volt, minus 1 volt?
Yes, sir. Yes, sir.
This is minus 1 DC voltage. The input, let me just also measure what is input. Channel 1 vertical
60.
average. Can you see it's 0.12? Almost 0.2. That's
Yes,
what we
sir.
applied, no? We applied 0.2. We applied 0.2. We are getting minus 1. That is, gain is almost close to minus 5.
1.
Minus 5.
Yes,
Because
sir.
it is
Yes,
coming
sir.
negative, no? Can you see the average of C2 is negative?
Yes, sir.
Average of C1 is positive?
Yes, sir.
This is an inverting amplifier with a gain of minus 5. Of course, here it is shown as 10. Maybe in that circuit, what we are actually using instead of 10K, I would have connected 4.7K.
Yes, sir.
Of course, otherwise it would have been there at around a gain of 10 means okay,
20.
0.2 into
2
10 would be 2
amps.
volt. It would have been 2 volt. Oh, sorry, minus 2
Yes.
volt.
Yes, sir.
Okay, any questions? I want one question from each group. Let me see how many of you are there with me. Okay.
Sir, what is the maximum gain I can get from this op amp?
No, maximum gain, if you keep on increasing the gain, bandwidth is keep on reducing.
Yes, sir.
So if you are looking at a larger bandwidth, then you need to compromise with the gain. So in this particular circuit, so whatever that we are getting is around 5.6 is the maximum gain I'm getting. Suppose if you change the physically a resistance of RF is equal to 100K, make R1 is equal to 1K, you can get a gain of 100. So that's what we do in your labs line.
Okay. So for any applications, I need both gain and bandwidth to be more, right?
You have to have a better op amp. That's where the entire circuit design happens to goes. If you want to have a larger open loop gain as well as bandwidth means your closed loop gain should be higher and higher.
Okay, yes, sir.
Okay, G1 group 1, do you have any questions? Group 1 members. Group 1. Hello.